Hello, ridegenesis team. Okay, so what we're going to do here is we're going to take a quick look at the motor controller and the microcontroller that is running in the equipment cage all the way at the bottom of the seat post. So the first thing I noticed, popped open this end of this first. I noticed that we had a big glob of thermal grease down there in the case, and that was right there where the corner of the board was. So I'm not sure if that's what the purpose of that was there. Probably just I don't know, an oops in the manufacturing process. But I noticed that as well. When this board is seated, it goes in this way, like so. And then 3 screws attach the heatsink that the FETs are on to the larger case heatsink. But one thing I noticed was that this was installed in this orientation in the bike. So if we pull this out and take a look, we've got our board up on top. It's not really where we want it for optimal heat dispersion. As well, we've got a bunch of heat sink up here that is not being used because heat flows up, right? These components, these power MOSFETs, are supposed to have heat conducted away from them this way. Or I'm sorry, this way. Out through the top of the case where there's no semiconductor material into the heatsink, up and out into the larger heatsink. I would think with a heatsink like is on this case here as well, that there should be some air moving around this device, I would say, in order to keep this optimally cool. But when you have it inverted, that heat that's being generated is flowing more back up into the semiconductor itself and up into the board. So that creates a problem. In worst case scenario, it should be installed with the label up inside the enclosure. So those are a couple things that I noticed there. There was kind of the smell of the genie getting out of the case when I opened up the enclosure itself. Not this case, but the enclosure to the bicycle. So there's nothing obviously burnt on here, but I did a little looking around, and the only other power supply, or motor controller rather, that I found that fit this form factor and set of outputs on eBay was, especially with this gasketed seal here and the shape of this gasketed seal, the only ones I found were 350 watt models, not a 500 watt model. Well, 500 watt motor, those lithium batteries, you hit them pretty hard. That's a 0.5 C rate if it's pulling 500 watts, because that's what, about a 280 watt hour battery or so. So that hits it pretty hard. It would cause a significant voltage drop, which is evident in the LED output on the bike control panel on the handlebar. So what I'm guessing is the failure here is one of these FETs, or more, one or more of these FET pairs here. And that could be due to heat. In fact, it's probably most definitely due to heat, or due to too much current being passed through it. I don't think it's an over voltage problem by any stretch of the imagination, because when you clamp down that much that much current through it, it causes a significant voltage drop on the smallish battery pack for that size of motor. Otherwise, the board build is, I don't have any problem with the board build. The assembly is kind of meh, in terms of the assembly of the case and all that. I mean, this big glob of thermal grease here is, I don't know, if you need to space it properly or use some padding or something, this is not the material to use that with. But there's a nice reinforced ground bus bar here, as well as a VCC rail for the FETs. So, you know, this is made to carry a decent amount of current, but what can I say? It looks like a 350. The only replacement part that's similar that's available on eBay for about, well, if you buy it in the States it's like $17, but if you buy it in China it's anywhere from $6 to $9, I think. The only replacement part that's even close is a 350 watt model. So if that's the shortage, then that could be the problem with the unit. Now I looked this number up here. Google doesn't know what to do with it, eBay doesn't know what to do with it, nobody knows what to do with it. So if y'all were trying to keep a secret 500 watt controller module secret, you know, hey, did a good job, but so there's that. The symptoms, it had low range. I found a mechanical fault in the brakes, which I'll show in another part of the video. It had low range, less than 5 miles, with a very minimal, I mean just barely engaging of the throttle. So I looked at the brakes, improved that. It had slightly better range and better acceleration, but it still didn't meet expectations. I mean, we're still talking about a 5 or 6, 7 mile range tops on a charge, and that's using, you know, very light pedal assist or minimal use on a relatively flat terrain here in Florida of the throttle. And when I say minimal, barely engaging it and leaving it that way. Okay, the battery. The original thought was that the battery was at fault. So here is the battery. Here's the battery with my keys in it. The battery has connected to it a Fluke multimeter, and you see it's on 0 volts. I'll turn this to the on position. Oh, I've still got 0 volts. Auto range. Okay, so I charged this day before yesterday. It's been basically sitting resting at this voltage 40.8. Okay, so that's our resting charged full voltage. If you can verify that that's what the voltage of the battery should be on a full charge, then we're good to go. It might be that we have a good battery here, but a bad FET in the controller, intermittently failing FET in the controller, was drawing extra current and negatively impacting the range. It's possible. It's possible that we have a partially defective battery here as well. If we remove the voltmeter, we stand it up, and this is kind of useless because, you know, I've used it until it wouldn't make the bike go anymore, which could be thermal. you know, problem after 5 or 6 miles on this, right? Used it until it couldn't make the bike go anymore, and then pull the battery, and it like gives me a full charge showing. I've had the machine shut off after about a 5-mile ride, showing a full indicator on the LED controller, or the LED on the left handlebar controller. The LED meter showed full. 4 LEDs. Okay, in a separate video I will show you the Offroader itself and the shape it's in presently, and then I'll put it all back together and show you what it's doing, which is basically you pop it in, you pop the battery in, the battery shows full, you turn it on with the key, you turn it on with the button, the on button, it shows full, you apply the accelerator at all, either way, and shut off. So, till then, cheers. Okay, we have a windy day here. You asked to see the condition of the overall bike. Here is the condition of the overall bike. I'll explain to you what I've done. So, there's no electronics in here now. They are inside on the bench. I will reassemble that and show you the symptoms of what is occurring. Basically, when I received the bike, the rear brake wasn't gapped properly. So what I had to do was pull the brake caliper off and slightly bend the mounting bracket this way a little bit in order to get it to gap properly. Now it gaps properly, it stops well there. What I had to do on the front brake to get it to gap properly was add some lock washers there, one there, and one, you can't see it. I don't think I can get a shot of it, to tell you the truth, but there's one up under there on the back end of this bolt, just as there is one on this bolt back there, and that allowed the front brake to gap properly. So you can see the overall condition of the bike. It hasn't been wrecked, it hasn't been damaged. What would happen is I would get, I would power it on here and I would get 4 lights, and I'd get about 5 miles out of it. And what was interesting was even right when it would die, I'd still have 4 lights there. You can see it's still in almost new shape. This is kind of hokey as well. I would think somebody could do a better job than that, but that's, I mean, I understand this has to come in and out quite a few times, but it doesn't really need to rotate in order to be able to get the battery in and out. Okay, thanks. Okay, so outside our bike is reassembled. Here we have the voltmeter on the battery. We got a green LED there. We got full charge going there. I'm going to turn this on. Voltmeter says 42.1. It's being charged. 42.1. 42 volt power supply. 42.1. Yeah, that makes sense. I'm gonna pull this power connector I like the use of the aviation plug, both to make sure that nobody gets it aligned incorrectly and to relieve strain on the wire, because you know people are going to be yanking on that thing. So that's a pretty good design decision. Okay, so we got 40.07 volts on the battery now, with the charger off, right? It says it's full. Now we're going to go outside, we're going to put it on the bike, and you're going to see what's going to happen. Okay, so here we go. We've got the vehicle on a jack stand here. We've got the electronics cabinet and area enclosure reclosed. That was a heck of a lot of surplus wire in there, and tracing them down, wound up pulling some out and just zip tying them to here for now, because I have a feeling I might have to pull that back out again so you guys can send me a replacement one. Still, we've got battery full there, right? We're in the on position. I'm going to turn the bike on. Okay. And then I'm going to give it a little bit of throttle. Okay, not bad, but understand there's no real work being done there. It's just pretty much spinning the thing, okay? So that part works. We got a horn, we got a headlight, there we go. That should prevent it from buzzing. Just so you don't think there's anything funny going on there. Okay, like I said, it's just spinning the motor at this point, not doing any real work. So, basically I need to show you what happens when I ride it, I think. So I'm going to take it out on a test ride and get it, it'll go correctly for a little bit, and I mean a little bit, and then it'll start to on the battery voltage. So I'll show you what I'm talking about here. Okay, so here we are. We're going to take it on a little street test here. You can see the battery is full there. This indicator shows full. I'm going to hand the camera off to my daughter. And I'm just going to ride around in circles and you hold the camera, okay? That's all you got to do.
Okay.
Okay, so just that little acceleration caused the unit to basically stall out, right? We got no power, we got no nothing anymore. You can see I didn't get on that real hard, I just pedal assisted it. I gotta turn it off with a key, so cut power altogether, bring it back up, power back on again, and I got a full battery light. Look at that. Okay, so now I'm going to pedal assist and I'm going to show you this as it goes, okay? Okay, here we go. You can see I'm on low pedal assist. And there it went. See that? Nothing. Now I can ride the bike, but basically for its intended purpose, its intended electrical purpose, it doesn't function. So now if I want to do it again, I gotta reach down here and turn the key off, turn it back on, turn this back on. You see it's got full power, right? Shouldn't be any problem there. Horn works.
Light works. Now I'm going to try to do this with, I'm just going to pedal once or twice to get started, and then I'm going to use the throttle, and you can see what happens. Alright, so this is just barely engaging the throttle. Okay, I have it barely engaged. And as you can see, hi there neighbor. As you can see, I'm barely moving. Barely moving here. Throttle's barely engaged. I'm going to give it a little more throttle. Alright, so I'm going a little bit faster, a little more throttle. But, now, there it went, see? Just a little more throttle. Now, what I'm thinking this is, I don't think it's the brake sensors. I don't think it's any of the sensors. I think it is the controller, the motor controller box, is undersized for the application. It's a 350 watt motor controller. It's a 500 watt motor, and the, what, 10 amp hour battery or 8 amp hour battery it has to dump a lot of current because there's a significant voltage drop. And before, when I would get on it like that, I would see voltage drop on these LEDs. In this case, we didn't. It just kicked out. Okay, now, I'll do it one more time. So there's no ambiguity as to what's happening. I'm going to turn my key off and turn my key back on. I'm going to turn on the machine. I'm going to give it just a littlest bit of throttle. See? Just a little bit of throttle. Not going very fast at all. And I'm going to give it a little bit more. And boop, nothing. Low voltage dropout. So either you've got a battery that can't deliver the kind of current that's required, possibly, or you got a controller that can't handle the current delivered. I think that's a little more likely a situation. So, if I'm manufacturing this product and a person like me comes along and makes an analysis of it like this, I'm probably going to send another motor controller for the electronics box right there, and another battery. Now, if you think it's the motor, if you think it's something related to that, well, I don't really think it is. I haven't tested the motor on its own because I guess it's a 3-phase AC motor, is that right? And I don't have a different controller to test the motor kind of on its own to see if that's what the deal is or what. So my guess is this controller got too hot. That's my guess, because too much current was being asked to be passed through it, because that motor is too big for that controller and that battery pack. That's my humble opinion on it. Do you guys know what it is? Send me the right part. If you don't know what it is, I'd send one of what's in there and that one to the battery right there. Thanks, fellas. Otherwise, it's a pretty good machine. One other thing I wanted to point out here. See these bare wires sticking out of this ungasketed hole? That's really no good. Eventually, that's gonna rub. It's gonna wear, and those wires are gonna short the chassis ground. So I see where you guys tried to put a piece of heat shrink tubing over that, but it didn't make it all the way down into the hole to prevent any wear or rubbing that's going on there. All right, thanks, Joe. Looking forward to having my ridegenesis off-roader fully functional so that I can take a 5 or 10 mile trip with it and make it home. Peace, fellas.